Hi friends, welcome to follow up. Let's have a look at problem 2366, minimum replacements to sort the array. In this video, we're going to explain a solution based on transforming the problem to be an optimization problem. So that's the one reason. Another reason that we want to do the video is that the solution by leetcode is actually not very rigorous, or more specifically, some of the reasoning is not correct. So here we are given a zero-indexed integer array called num. In one operation, we can replace any element of the array with any two elements that sum to it. So for example, if we consider 5, 6, 7, so one operation can be this, right? We can split 6 to be 2 and 4. So here our goal is to return the minimum number of operations to make an array that is sorted in a non-decreasing order, right? So here we have two examples. So example one actually is very special. If you look at the number after 9 and the number before 9, so we can actually split 9 to be 3, 3, 3, right? So this way we need two operations. So the return is 2. And in the second example, this is also very special. The reason is that so this list is already in sorted order, so the output is 0. So overall, the two examples here given are not very representative or with great generality. But this problem itself is an interesting problem, right? So here the constraints are the following. First, so the length can be as long as 10 to the power 5, right? So a typical computer, it can deal with 10 to the power 7 operations in a second. So here, if we see, we need to think about temp complexity actually. So for example, if we use n square temp complexity solution, so it might not be able to pass the all the tests. So the second one is on the range of the elements in the list. It's positive and it can be as large as 10 to the power 9. So this is the problem statement. So here I will regard this problem as mainly some reasoning. So the coding part actually is rather straightforward, right? So here we want to use some abstraction, right? Once the problem is abstracted to a model problem, solving it is very simple. So here our procedure will be the following. So we're going to look from right to left, right? If we see a current number is larger than the element to its right, so we need to break this number, right, in order to make it sorted. So if the current number is smaller than the right, the next number right to it, so it's normal, right? So here the main question is how do we do the break, right? So the criterion is very clear. We need as less operation as possible, right? The second thing we need to notice that is that during the above linear traversal, so we want to use linear algorithm, right? So we need to update the counts. So here the problem actually is the following. If we realize this procedure, so given a reference value, say a number y is greater than or equal to reference, we select to break y into key number such that we want key as small as possible. So such that this sum equals this y, and right. So we can assume that this are sorted. It does not matter because right. So then we want that all the numbers is less than or equal to the reference um, uh, number, right? Also, because it's sum to this number, of course. And if the largest one is less than or equal to the ref, then every element will be less. And also, we want this A1 to be the smallest among this, to be as large as possible. Because this way, if we consider the even left elements, we can use less total operations. So here the strategy is the following. We want to break y into copies of reference, right? So for example, if y divided by the reference equals k, and there's no remainder. In other words, if the remainder is 0, so we just need to break this into k copies of the reference, right? So in this case, we need k minus 1 operations. So another case is that if y divided by the reference is not a multiple of reference, so we need to break y into k plus 1 parts, right? So here we can consider a1 equals the y interdivision by this k plus 1. So this a1 will be the largest possible among the sum that sums to y, right? So here, actually, we can give some rigorous proof, but for our purpose, uh, we can first check why this should be the largest possible. So we can argue by contradiction. If a1 is greater than this, and then because it's the integer, so this will be greater than or equal to this integer plus 1, right? And if we sum all these things, it will be greater than k plus 1 copies, right? So because k times this one will contain an integer part, then um, plus k plus 1, but k plus 1 is larger than the remainder. So overall, it's strictly larger than y. But the sum is y, is contradiction. Therefore, the largest possible a1 we have is this number, right? So with that said, basically we can do the split. For example, we have reference is 5 and we have 11, right? So this is the one way to split, but this is not good because if we look at this one, it's the 1, then former numbers will have to be broken to be 1. So this will induce a large number of operations. So in this case, we want to say 11 divided um, so for example, 11 divided by 5 is 2. So we want to split into 3 copies such that their sum is 11. So the A1 will be y interdivision by 3, right? That will be 3. So we have 3, 4, 4, right? So here is another example. You can look at this one, right? So if we scan from right to left, then we see that 7 is greater than 6. So in this case, it's better to split 7 to be 3 plus 4, right? And check. So here we cannot break 7 to 1 plus 6. If you do this break, then 9 and 12 must be broken into 1. This induces yes, large number of operations. So after the break, we will have something like this: 12, 9, 3, 4. So we do not care about remainder ones because they're already in sorted order. So now we have 9 is greater than 3. But in this case, we have interdivision with no remainder. So we just split 9 into 3 copies of 3 to get this. So we get something like this. Then 12 is divisible by 3. So we break it into 4 copies of 3. In other words, 3 operations. So if you total them together, it gets 6 operations. That's the example. I guess this example is more general or representative than the two examples given in the problem statement. So if you examine the solution, the solution or the coding part for this problem is rather straightforward. However, digest this problem and understand the reasoning is another level, right? Or another aspect. So here, let's do this. So we have n. This is the length just for convenience. And then we are going to start from, so let's initialize the result. We are going to return its final state for the counting. And the first reference value will be num-1, because this is the largest possible, right? So we want to break from right to left. So for I in range, so we start from the largest index in nums Ri. If it has length n, is n minus 1. It's corresponding to this number, right? But here we start from n minus 2, and then ending at 0. So we write -1 here because this is not included in the range. And then what we want to do, if nums I less or equal than the reference, they're in correct order, so we just need to update the reference to be the current number and then continue, right? So otherwise, what we want to do, we want to do integer division, right? So this problem actually tests how what's the depth of our understanding about integer division, right? So here we're going to, in this case, nums I is greater than the ref in strict order. So we are going to do this and do reference, right? So notice that reference is always larger than zero, right? Because the assumption nums is greater or equal than greater than or equal to one, right? So in this case, we are going to check if r equals zero. So in this case, we need to break this into uh, q minus one q copies, that is q minus one operations, right? So in this case, because we break the current nums I into identical copies of the reference value does not change. Otherwise, so we need to divide the numbers nums I into q plus one copies. So in this case, the number of operations needed is q, right? And the reference value, as we explained, will be nums I. So integer division by q plus one, right? So this part is important to understand. And then if you understand this part, and then you can come back again to understand this part, or you can work out some example by yourself. Then you get a better understanding about the logic here. And then we just need to return the state of the result. So before we make any comments, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yes, it passes all the cases. Actually, another reason for we do a video for this problem is that, so long time ago I worked on this problem and solved it, but today when I do it, I made several mistakes, especially when I do the increment. So here I wrote q and here I wrote q plus one. So this is tiny details, but it's we need to pay attention to such tiny details to make it right overall, right? So with that said, that's about it for this video.